Good evening, and thank you to especially Ilani and the organizers for giving this opportunity. If my slides are not clear, and you can stop and you can disturb me, not a problem. So here, my today topic is expanding the reach, integrating AI-generated auto contours via deep learning segmentation into diverse treatment planning systems. It looks complicated, but in radiation oncology, we are using a treatment planning system. In that one, the contours, auto contours we can do here, and we can share it to n number of locations. That is the meaning. So whoever is in radiation oncology working, dosimetrist and physicist, and even some medical oncologists, surgical oncologists also, they know about this. So aim I already shared with you. This is integration of AI-generated auto contours with other planning systems through cloud system. This is first of its kind in India, and we have even presented this and published also. So if I tell from the beginning, you can understand what is the importance of this. You all know that in the Indian population, in India, 1 out of every 9 individuals is expected to develop cancer during their lifetime. In 2022, the estimated number of cancers is 1.4 million. Okay, with a crude is rate is 100.4 per 1 million people. More than 50% of cancer patients require radiotherapy as a part of their treatment. So, access to the radiotherapy is a real issue here. So, access to radiotherapy remains limited, especially in low and middle income countries. According to the IAEA data, around 1/3 of the countries still lack access to the radiotherapy, with 28 of these nations located in Africa. So, if you don't have access to the radiotherapy, forget about good planning system, which is planning for radiotherapy, and also forget about the best contour software. So for best planning, contour is the soul. Contour is nothing but delineating tumor, normal structures, and body. Contour of the structure require high skilled manpower, right? Like radiation oncologists, medical physicists, a trained dosimetrist, okay? And time. It takes minimum, if for a best plan, it takes minimum 1 to 3 days. And proper planning systems with contour application also required. So all these things you cannot get in all the hospitals in remote villages and in remote places, either in India or in abroad. So the main task of our Karkinos, our institute, is with minimum planning systems, and by integrating with multiple systems, locally, remotely, through cloud system, how to implement this high-end technology through deep segmented auto contours. So now, before going to my next slide, why I'm talking this? What is the disadvantage of this so-called manual contour we have been using? Manual contour is associated with several challenges. Firstly, contouring is time consuming, as I already told you. This could affect the treatment outcome due to the delay in the start of the treatment. For example, contour takes 2-3 days, patient has to wait. And after planning is there, after that quality assurance is there, it will make total delay in the treatment. And manual contouring is subjective. As a radiation oncologist or dosimetrist performs the delineation of OARs, and means other organs at risk, based on their previous experience and knowledge, which is a source of inconsistency. Whatever they know, that is the maximum they can give. Several studies have shown high interoperability in contouring, which may lead to inappropriate treatment during treating normal areas. So now, what is the advantage of auto contour? So far I am talking. So it reduces this time. So it reduces from 2 to 3 days to the few hours, and beneficial where shortage of radiation oncologists or expertise is required, and also to maintain uniform protocols across all our country institutes. For example, we have one institute at Imphal, one institute at even Andhra Pradesh. Wherever it is, almost 2,600 patients so far we did with auto contour, all have uniform contours, which we can say proudly. So we can compare tomorrow apple to apple, not apple to orange. Moreover, the standardized contours facilitate better tracking of patient outcome and post-treatment, because this is built with almost big data of more than 40,000, plus it's go on adding. And also it is best for the database research and anything else. So coming to this, first of all, what is auto contour? Automatically generate contours of all relevant region of interest is called auto contour. So which method we are using? Deep learning segmentation, which is able to learn from unlimited number of patients. That is the method we have been using this. So what is deep learning? So there are so many people are clinicians here and biomedical engineers, advocates. So I don't want to go deep in it, but just one or two slides on deep learning. This is a technique which is able to learn from unlimited number of patients and still automatically generate contours of all relevant region of interest in under a minute. That means it can take, for example, 30 to 40,000 patients data, and due to its deep learning, means the data that we acquire, so it will give the either bladder, rectum based on that data, and another one based on the other data also, the unit network, unit technology that also I'm going to talk. So these two adding together combination, it is generating. That's what in the figure it is explained. So the deep learning segmentation is an automatic method that uses machine learning, and unlike manual delineation, which is time consuming, it makes us very fast, and it do in CT, CBCT and MR images, not limited to only CT. It's not intended for identifying lesions, but focus on delineating anatomical structures. Of course, it can even identify the tumor, but that is not ethical, and the clinicians are there, and it is not as per the protocols. So right now, total across the globe, auto contours we are using for the normal structures. That means other organs at risk. So how it will work? As I told you, RayStation utilizes deep learning technique. That's sufficient for this topic now. These models can generate contours of various body sites. That is another one. These two combination, it is doing the computation time is moved offline, means that is about the IT. So the processing time. So once the model is trained, producing new segmentation is very fast. So within minute, we can generate almost 60 to 70 contours. So as I discussed, CD, CBCT and MR images, we can delineate, and this is work on the voxel base, and the result from the training is called network, okay, and can be looked upon as a non-linear function, taking a three-dimensional image as input and producing labeled image as output. So this is the method, and we are using anyway RayStation planning system, and 3D unit is the technology that we are using in this. Here what happened is, uh, the RayStation planning system we kept at the central station, and we are connected to other planning systems across India, different various planning systems. We could able to speak all these planning systems with each other. That's called central planning system. So then what we did, this is the architecture, the TPS, CT mission, PAX missions. OAS, linear accelerators, all these are integrated each other. And these are the CT details. All in our institutes, we have CT mission, we have LINAC mission, we have HDR and PET CT. So this is because why I am showing the CT is the images that we are getting from CT is first transferred to the cloud. So what are the CT scans we are using? Siemens we are using, Wipro we are using, and so many other TPS, OAS are also there here. And these are the KVP, MAS, and field of view specifications of various sites like brain, head and neck, breast, thorax. So now coming to the deep learning QA. So deep learning segmented auto contours, we cannot believe because this technology is so advanced. ML, machine learning, AI, artificial intelligence, they are moving like so fast. So sometimes it may cause the damage, like previous one of the speaker told. So we have to check with this. So we checked with the consistent with AAPM TG 263 and for any further treatments. This is the RayStation planning system and database server. It looks like this. And this is the architecture I have shown you already. These are the number of filters we made at the central planning system. And CT images from any location can be imported to A position, and from there we can again send back to any station after auto contour. That is the beauty. So this is the RayStation we have. For example, this is in location A. They can do auto contour, send it. They can do scan and send it here. We can do auto contour and send it back to that particular location. Or if, for example, I can send it to any other location also. So this is exporting images from CT to RayStation in the cloud. We can select any filter, and while importing, we can import it to a particular station. For example, if it location A, location B, that is the one. And after that, again, we can select it is head and neck or pelvis or breast, whatever it may be. That model also we can select. So we can do auto contours here. So these are all the auto contours which is generated within 1 minute. And here is the 3D view. And what we do after that, treatment planning system or OAS or QA for any device. These are some of the imported auto contour images in various planning systems like Eclipse and Monaco. These are examples of some patients. The results is these OAR contours generated through deep learning segmentation in RayStation were seamlessly transferred to both Monaco and Eclipse TPS via cloud connectivity. Analysis revealed that the most of the contours were deemed perfect and utilizing in clinical planning. After all, it is saving 2 to 3 days time of any oncologist or physicist. In our institute, successfully we established RayStation on Microsoft Azure, that is our cloud system for the DCCN network. Our organization is pioneering a new era of distributed cancer care with a cutting-edge cloud-based solution in India. So the conclusion is, by integrating AI-generated auto contours via any planning system, here I use RayStation, we can send it to diverse treatment planning systems. This can be used in any of your country so that you can save a lot of amount. You know that a crores of rupees, the vendors we have to pay for one license. Now with this technology, we can use with one license to the 5-10 institutes. That's what we are doing. This will definitely help you. We could able to come down the contour time also 3 days to 1 hour, even for remote areas where there is no contour expert available. Also, no need of a very good expert radiation oncologist in remote areas. This method not only translates to significantly time saving to start planning and treatment, but also ensure uniformity of contours across all our units. Now, whatever the breast contour in Imphal we do, same thing we'll do in Andhra Pradesh, same thing in Kolkata, same thing in Mumbai. So that is a beauty. Tomorrow I can do research, I can compare these plans, I can get the results while doing the same contour. This consistency fosters enhanced quality in treatment planning, facilitates research endeavor, and ultimately contributes to improved patient care, especially in developing countries where the budget for dedicated treatment planning systems are not adequate. So, hope you all understood what I want to say. Thank you.